All right, welcome back. Let's go ahead and deal with some exponential equations that we will need to do a little bit of more work with. Okay, so let's start with this first one. 2 to the x power is equal to 12. Now, we can try to relate the bases, but there's no way, there's no power of 2 that gives me 12, because if you think about it, oopsie, 2 to the third power, that's 8. 2 to the fourth power is equal to 16. There's not really a number that can get me, there's not there's not a nice number that'll get me exactly halfway between, which is where our 12 is, right? It's not 3.5 if you're thinking it's 3.5. So we need to figure out how to get to 12, right? Because if it's not going to be 3 or 4. So we need a logarithm, okay? Maybe our first instinct is to rewrite this as a logarithm. Log base 2 of 12 is equal to x, but we still run into the same issue. We don't know what log base 2 of 12 is. We also can't put that into our calculator, because if you look at your calculator, you only have log base 10, the common log, and the natural log. You have log and ln buttons on your calculator if you're using the TI-30X2S. Now, if you have one of the newer, fancier calculators, the fancier graphing TI-80 series, or if you have like a really fancy Casio, or if you go on Desmos, you can find log base 2 of 12. We won't always have access to those. Sometimes we'll only have access to our little TI-30X2S calculators, or sometimes we'll only have access to the ones on our phone. So we can't really do this right here, because we can only calculate this if it's log base 10. So what are we going to do? Here's what we're going to do. So we're going to go ahead, and there's a property. Okay, you might want to write this down on the side. There's a property of logarithms that says log base, let's say a, of x to the r power. Okay, if we have something like this is equal to r times log base a of x. Now, this might hopefully will ring a bell from algebra 2, right? Because this should mostly be review. But this property lets us, if I go ahead and I take the logarithm of something that's raised to a power, I'm allowed to bring that power to the front as a constant. And that's really nice, because now this normally is something that we know, a number, we can just divide it over and then have r by itself, okay? So let's try that here in this first example. So what we're gonna do is just take the logarithm of both sides. We're gonna use the log base 10. I can actually use log base 10 or the natural logarithm, because they're both gonna be giving us the same answer. And they're both in our calculator, so we wanna take advantage of it. So let's take the log of 2 to the x power equals log 12, okay? It's a function, it's a one-to-one function, so I'm allowed to just do this. I'm allowed to just take the log of both sides. Okay, now I can use my property here. I can bring this x to the front, and that is really good because I want to solve for x, right? And now that x is a whole number constant in the front, I just have log of 2 left. I can solve for it, because what is log of 2? It's just a number. I don't know what that number is off the top of my head, but I can actually put that into my calculator. So since it's just a number, I can just divide both sides by log of 2. Okay, so x is going to be the log of 12 divided by the log of 2. Now do not, this is not log of 12 divided by 2. Okay, do not try to shortcut that. This is no, don't do this. Okay, bad. All right, let's put it into our calculator. We just got to do log of 12. Now go ahead and just do log of 12 and press enter. Okay, 1.079. All right, log of 12, remember what that's asking. That's asking what power, because remember that's base 10. What power do I take 10 to get 12? Well, we don't know that, because 12 is not a nice whole number power of 10. So it's going to be some other number, some irrational number, or some number that's not just a whole number. Okay, so a log can help us find that. And in this case, it's going to be 1.0979, about. Okay, so if I take 10 and raise it to the 1.0979 about power, I get 12. All right, that's what that means. That's really what we're solving for. Okay, so let's figure out what this is. We're gonna get an approximation because this is gonna be not a really nice number. So let's do log of 12 divided by log of 2. We're going to get approximately 3, let's do 3 decimals, 0.585. Okay, so that's our x answer. X is approximately 3.585. Okay, so 2 to the 3.585 power is 12, right? And we kind of knew that because we knew 2 to the 3 and 2 to the 4. We know 2 to the 3 was 8 and 2 to the 4 was 16. And since 12 is between these two numbers, we know that the x value would have to be somewhere between. Okay, so cool. Let's keep going. Let's try it with some other ones. Start on the next one. Okay, all I have to do is take the logarithm. Let's do the natural log to show you that it works just as fine. So natural log of 1.23 to the x power is equal to natural log of 27. Okay, let's go ahead and bring this x forward using that property. X times natural log of 1.23 is equal to the natural log of 27. I divide this over because it's eventually just going to give us a number, okay? Don't let the natural log thing scare you. It's just going to be a number eventually. Okay, so divide it over. X is equal to natural log of 27 divided by the natural log of 1.23. Let's punch this into our calculator. Natural log of 27 divided by natural log of 1.23. That's going to be approximately, so x is approximately 1, not just 1, 15.921. Okay, so 1.23 to the power of 15.921 gives us 27. Pretty cool. All right, now just to show you that if you used logarithm here to you would get the exact answer. If I replaced all of these with log, I would get log of 27 over log of 1.23. Put that into your calculator and see what you get. Log of 27 divided by log of 1.23. Okay, you should get the exact same answer, 15.921. Okay, they're the same. All right, it has to do with the property of logs and their ratios. We're not going to get too much into that, but because of the structure of the logarithm, you're always going to get the same thing when you do that. Okay. So when you do this process, you guys, you can either use a log base 10 or a natural log, whatever floats your boat. They're both pretty cool. Okay, 2 more examples and then we will be on our way. So the first one, okay, we can go ahead and just start with a log. So log of 3 to the power of x plus 2 is equal to 2. Log of 2, sorry. Okay, so notice this. Our exponent is x plus 2, so that whole thing comes down. Let's do it in parentheses, okay? So x plus 2 quantity times log of 3 is equal to log of 2. Okay, let's go ahead and divide over this log of 3. All right, because that's just a number being multiplied in. I get x plus 2 is equal to log of 2 over log of 3. I want to solve for x, so all I got to do is subtract 2. So minus 2 at the end. Okay, so first put log of 2 divided by log of 3 into your calculator. Then whatever you get from that, minus 2. Let's do that. Log of 2 divided by log of 3. And then I do minus 2. Okay, we should be getting x is equal to negative 1.369. Okay, so that's our answer. So if I plug that in for x, we get that it's true. All right, one last one to send us home. And this is going to look a lot like the stuff we're going to see in 4.3. All right, we have 10. Okay, this is an implied multiplication. So 10 times 2. That 2 is being raised to the power of t divided by 6, and it's equal to 50. Okay, so we're going to solve for t. That's our objective. But remember, we want to get the exponential piece by itself. Always get the log or exponential by itself first. How do we do that? Well, we're going to start by dividing by 10 on both sides. Okay, so 2 to the power of t over 6 is equal to 5. Now here I can take a log or a natural log of both sides. Let's do natural log. So natural log of 2 to the power of t over 6. T over 6 is equal to natural log of 5. I can use my property to bring this exponent down. I get t divided by 6, or t over 6, times natural log of 2 is equal to natural log of 5. Divide both sides by the natural log of 2. That simplifies out. We get t over 6 is equal to natural log of 5 over natural log of 2. Okay, to solve for t, we just multiply both sides by 6. I ran out of space. Let me move this down. So our final answer that we put into our calculator is t is equal to natural log of 5 over natural log of 2, and we'll multiply that by 6 when we get it. Okay, so let's do that. Natural log of 5 divided by natural log of 2. That's 2.322. Multiply that by 6. We get t is approximately, 13.932. Okay, cool. We got our answer. Now, just to give you a little perspective, there's no context to this problem right here, but really what kind of could happen here is, let's say we have, I don't know, like a population of rabbits. That starts off with 10, right? Our initial population. There's always a number in front. And then in here, it's kind of disguised, but remember, it's 1 plus r for that, it's the x power for that exponential growth. So really what our growth rate here is 100%. So this 2 signifies that it's doubling. So I have a rabbit population that's doubling by, doubling. I don't know why I was going to say by something. A rabbit population that starts with 10 and it's doubling. How long is it going to take to reach 50 rabbits? Okay, well, it's going to take 13.932. That's what that significance is. Now, this division by 6 has something to do with how long it takes to double, right? So there's kind of a certain increment of time that it takes to double. So then we go ahead and use that to then figure out, well, based on that time that it takes to double, how long then will it take to reach 50 if it doubles within a certain time period? All right, so that's kind of what this could represent. I'm not saying it does represent that, but it could represent that scenario there. Okay, and we'll see that a lot in 4.3 when we wrap up chapter 4 in our next lesson. Okay, that's it for D.2. Hopefully this was a pretty good review for you of how to solve exponential and logarithmic equations. Like I said, it'll be good for us to know when we venture off into 4.3. All right. Hope you guys have a good rest of your day. I will see you later. Bye-bye.